Thank you for watching our DevNet Create presentation, SecureX Orchestrator has a wingman, hybrid cloud workflows using a sidecar pattern. I have a question for you. Have you ever wanted to build a tool that could be used and augmented by people on different teams? What if one group likes Bash scripts, another group uses Ansible, maybe you have some Python programmers, and you also have some folks that don't know how to program at all? Hi, I'm Stephen McNutt, and I'm a systems architect for Cisco Systems. I've been in the information technology industry since 1995, and I've held various roles ranging from individual contributor to owner. I'm also a DevNet professional. I'm very excited to speak with you today about our project.
Hi, everyone. My name is Nick Russo. Like Steve, I've been in IT for quite some time, done a lot of advanced network engineering, and more recently, a lot of network automation. I'm currently a technical leader within CX, and I'm excited today to share with you a solution that we built that we think is going to be flexible and extensible that you can use in your environment.
Now, about that question I asked you. Today, we're going to talk about SecureX Orchestrator. We're going to talk about his trusty helper, Sidecar. And so let's just go ahead and jump into it. So first, what's SecureX Orchestrator? Well, it's a component of SecureX, which is a product that comes free with all qualifying Cisco security products. It's a SaaS application, which means it lives in the cloud. You don't have to install it. You don't have to patch it. It's just always there. You can use it whenever you want it. It uses drag and drop logic. It's technology agnostic, and it will talk to pretty much anything. So why would you want to use SXO? Well, first, it's really easy to wire up inputs and outputs using a variety of protocols. So it can talk to just about anything you can think of. And it has a lot of built-in modules. And you can also make your own if that doesn't have one that already does what you need. It also comes with a standard set of programmatic constructs that you would see in any typical programming language, such as loops, conditions, variables, and things like that. And finally, because it uses a graphical drag and drop user interface, you don't need to learn a programming language in order to start using it. You can just log in, grab your mouse, and start making things. Now, the next component we're going to look at is something called Remote Connector. And all Remote Connector is for is to allow us to reach into remote infrastructure and make calls to devices there. Finally, let's look at the sidecar. A sidecar is a helper virtual machine, and it's going to live on the same networks as your targets. So this is something that you're going to place close to the things that you want to do work on. And this is where your IO intensive, input output intensive data processing is going to live. If you have any sort of kind of complex processing logic or anything like that, this is going to be a really good place to put it. So let's connect the dots here. So how does this work? Well, the general pattern is SXO is going to send a call out to Sidecar saying, hey, do a thing. Sidecar is going to go out and do a thing, and then it's going to return that result to SecureX Orchestrator, such as, success, failed, gosh, lol, I don't know, but something will happen and we're going to get a result back. And with that, I'm going to turn this over to Nick, and he's going to describe our specific use case.
As Steve discussed, we've developed a generic pattern to solve a specific problem. So next, we're going to talk through what that problem is. And specifically, our problem was, how do we connect a branch site? And this is just your classic, remote site, like a store selling a product, a bank, anything like that. And what we wanted to do was we wanted to provide a centralized internet backhaul to rapidly ensure that these sites could be connected back to a data center or a corporate headquarters. So within that, there are some benefits to that approach. We can leverage powerful security services at that head end, whatever's there. And of course, there are some drawbacks as well. But the biggest and most difficult thing to solve for us was, how can we do this at scale? So coming up next, let's talk about what that solution looks like at a high level. We decided to use Cisco's umbrella SIG, which is Secure Internet Gateway. If you're not familiar with this offering, it is a SaaS solution that effectively allows Umbrella to host a IPsec head-end virtual instance where you can create tunnels on the head end, and then clients like routers and firewalls can form VPNs towards that head end to backhaul all their traffic. And this is useful if you have hundreds or thousands of branch sites that need to be stood up rapidly. Think something like disaster response, where you have all these remote sites that need centralized access, and you can provide it in a snap using this solution. And it not only scales really well, but we want to be able to provision it quickly to provide those services. So coming up next, let's talk a little bit more about how that solution works. And we'll see on the next slide what the high-level architecture looks like. Now, I'm not going to detail too much here. We're not going to review any code. We're not going to dig into the Python because it's probably 200 or 300 lines of code if memory serves. First thing we have to do is have SXO load in our devices. This is the concept of an inventory, if you're familiar with Nornir or Ansible, with a know what devices we're communicating with. And for every site that we have, there's going to be an associated sidecar on that local network. A sidecar is registered back to SXO, almost like a proxy device that can take commands from SXO and run them, running scripts or whatever else on the local devices. So we configure our remote device to connect to Umbrella using NetMiko over SSH that provides support for legacy devices. And we also use the REST API, specifically the Umbrella Management API, to create the SIG tunnels at the head end. Once the tunnels are configured, we wait on the client device to make sure that the tunnels come up. We send some traffic, and we also ensure that the tunnel reports up on the Umbrella side. This guarantees that the entire system is working, and you'll see in the demo, Steve will talk you through exactly how that works. So coming up next, Steve is going to talk through the software level architecture on how did we have to build this sidecar, because this is something custom we had to build to support our specific use case, but it has broad applicability beyond just Umbrella SIG. So Steve's going to talk about that.
Thank you, Nick. So let's take a closer look at this sidecar. So this is really a very common microservices type of pattern that we're looking at here. So SXO sends a post out to a configure endpoint on a server, which is just Flask, right? And then the Flask application acts as our web front end. It takes all of the parameters that SXO sends, it drops it into a Redis acting as a message broker. Now, in a lot of designs, you'll see RabbitMQ used here, but for the sake of simplicity, Redis can act as both a key value store and as a broker, so that's what we decided to do here. So finally, after that, Celery picks up the messages from the broker, and then it sends all the tasks out to workers. So these individual workers take a copy of Nick's script, buildsig.py, and it runs them. And so each copy of buildsig logs into its assigned branch router, configures it, and then also makes the API calls up to Umbrella to build the tunnel on the back end. What's really nice about this design is the actual code that's running against the devices that's doing the work doesn't need to know anything about concurrency or queuing or anything like that. That's all handled by Celery and Redis. That's really the beauty of this design. So you can take any kind of script and just drop it into this design and start using it. So that's basically how this works. So now that you've heard the descriptions and all of that kind of stuff, let's actually run a demo. Okay, so this is the network tunnels page on Umbrella, and here we're just verifying that we don't have any tunnels configured yet. Next, we're going to take a look at our SXO workflow. We begin with a sidecar liveness check, just to make sure our sidecar's up. Next, we're going to load our devices in from the database. And then for each device, we're going to loop through and send out a provisioning request to our sidecar. When that happens, we're going to get back a task identifier from Celery. We're then going to take that task identifier and we're going to store it in a tracking table for later. In the next phase of our workflow, we're going to use those task IDs to basically sit in a polling loop and wait for all the tasks to complete. Once all the tasks are complete, the workflow is done. So let's go over now and take a look at the database. As you can see, it's just one table with some columns that just has all of the parameters that we're going to need, and we're going to use these as input into our workflow. So now we're going to take a look at the router, or one of the routers that we're going to configure just to verify that it's currently in an unconfigured state. So right now it has tunnel 20, which is the existing tunnel back to the data center. So we're going to add a tunnel as part of this workflow. So let's take a look at the routing table. We can see we have a default route that points to that tunnel that goes back to the data center. So now that we've verified that our router is in an unconfigured state, we're going to go ahead and bring up our Docker Compose app that runs on the sidecar. And that's going to fire up our 3 containers. So we have our Redis, and we have our worker, Celery worker, and we have XSO Sidecar, which is our front end. Okay, so our app is up and running now and ready to get going. So what we're going to do now is we're going to pivot back into SecureX Orchestrator, and we're going to go ahead and we're going to kick off the workflow and then quickly switch back to watch what's happening on the worker. All right, so now you can see all of the configuration requests have already been fired out, and all the workers have logged into all of the routers. So now the routers are being configured by all of their individual worker scripts, and they're also logging into Umbrella on the back end and sending out the API calls to configure the tunnel. And we're done. It only took about 20 seconds. So what's happening now is we're just probing and waiting for the Umbrella backend to configure the tunnels. We're going to speed this section up a little. All right, so now we have tunnels up, and what we're doing is we're probing and waiting for routing to converge. And momentarily we should have routing. Okay, so we now have routing. So now we're passing traffic through Umbrella SIG. And if you look below, you can see that tunnel 100, which is the SIG tunnel, is now up. And that's going to be our default route. All the traffic is now going to flow over tunnel 100 towards SIG instead of tunnel 20 towards the data center. Here we can see all of the values being returned from our scripts. They're being stored in Celery, and then SXO is getting that status information back. So now we've completed the run. The workflow's done. So we're just going to take a quick look inside of Flower, which is just a way to inspect what's happening inside of Celery. So we can see we processed 10 requests. They all succeeded. So this is the task ID that gets returned back to Orchestrator. This is the second column is the parameters that were actually sent from Orchestrator to Celery. And then finally, this last set of values is what's returned from the script that configures the router back into Celery, and then Celery sends us back to SXO. Let's verify our tunnels in Umbrella. And as you can see, we now have 10 active tunnels and everything's up and running.
All right, everyone, with the demo now complete, you've seen how our solution solves a real life problem using a generic design pattern with a specific instance of an implementation of that design, I should say, to solve a specific problem using Umbrella SIG. So coming up next, I want to summarize a few key points. So we used SecureX Orchestrator, or SXO, to build all the high-level logic, the inventory management, the database management, managing the worker and tasks, handling the control flow, and orchestrating the whole solution. That was all done with SXO, all that logic. Now, the actual configuration of the devices and the configuration of Umbrella was done using just a basic Python script that stands by itself. There was no concurrency and nothing special about it. That's the kind of basic network automation that a lot of engineers who are new to this business already know how to do. So with the skills that many of you already know, you can add the concurrency and the fanciness of SXO to solve problems at scale. And that was really the big take home today. Also keep in mind that the sidecar was an important component of the solution, which lives on site with the customer devices, the routers and the firewalls being managed. This ensures that SXO doesn't have to reach into the network because that's oftentimes a security risk that a lot of businesses are not willing to tolerate. So all those components, as you've seen in the presentation, we've had the diagrams for it. We tried to explain how all that works, and then the demo hopefully tied all that together for you. So coming up next, the last thing I want to say is thanks for attending our talk. We hope you enjoyed it and enjoy the rest of your time here at DevNet Create.